In this video, we will examine a fair gamble. Imagine you make a $1 bet with a friend on the outcome of the flip of a fair coin. You win $1 on heads and lose $1 on tails. The expected value, or average return from playing this game, is 0. Over many repeated bets, you can expect to win as often as you lose. The expected value is the probability of a win times the prize for winning, and the probability of a loss times the prize for losing. In mathematical terms, the expected value equals 0.5 times plus $1 plus 0.5 times minus $1, which equals 0. A fair gamble is a wager with an expected value of 0. Let's change the wager. Now you get $10 if you win, and you give up $1 if you lose. The expected value shown here is $4.50. If the game still costs $1 to play, it's no longer a fair gamble. You expect to win if you play, and many people would eagerly take this bet. How much would you be willing to pay to take this wager? Who would pay $1 million for a fair gamble like this? If you win the coin toss, you get $1 million. If you lose the coin toss, it costs you $1 million. One of the first people to study the reasons for this unwillingness to engage in fair bets was Daniel Bernoulli in the 18th century. His examination of the St. Petersburg paradox was the starting point for virtually all studies of the behavior of individuals in uncertain situations. The following gamble is proposed in the St. Petersburg paradox. A coin is flipped until a head appears. If a head appears on the nth flip, the player is paid $2 raised to the nth power. Thus, if a head occurs on the first flip, you get $2, on the second flip $4, on the third flip $8, and so on. This gamble has an infinite number of possible outcomes because a coin could be flipped for all eternity without a head coming up, although that's not very likely. Note that the probability of a win decreases with each toss, from 1/2 on the first toss to 1/4, then 1/8, and so on. The expected value of the gamble shown here is infinity. To make this a fair gamble, one would have to charge a price of infinity to play it. It takes you less than a second to know this is a bad deal for the player. No player will play very much to take this bet. The paradox is that Bernoulli's gamble is, in some sense, worth less than its infinite expected dollar value. Bernoulli addressed this paradox by arguing that individuals do not care directly about the dollar prices of a gamble. Instead, they respond to the utility their dollars provide. That is our next video topic.